All right, so let's kind of recap a little bit about what goes into setting these up, okay? So if I look back over here at our rules, remember, you do not have to do the similar triangle stuff, okay? You can. I wouldn't necessarily suggest it, but it's kind of like a worst case scenario. If you understand it comes from similar triangles, you could set them up if that's the only way you can do it. But these really are not that bad and not that hard to remember, okay? People always make it out like it's that much more of a big deal than it really is. The things that get squared, there's only 3 things that really just boil down to 2. And these little equations, the only things that get squared are the legs. So there's 2 of those, which you can kind of count it as 1, just it's a leg or it's not. So each of the legs could possibly be squared, or the altitude. That's it. Then everything else comes from the hypotenuse. You have the entire hypotenuse and the 2 pieces. That's how you get what's on the right-hand side of the equation. Okay? So it is either what gets squared is a leg or an altitude, and then these right here come from the hypotenuse, either the pieces or the whole thing. Okay? So that's what we did here to set these up. Z squared is equal to the piece that's attached to it times the whole thing. And I've had a couple people today really just, I don't understand why you use the 2. I don't understand why you use the 10 over here, that sort of thing. So just to make sure that we're all on the same page here, this leg touches the 2. Okay, right? This is the hypotenuse. It gets cut into 2 pieces. So this leg touches the 2, that piece, and the entire hypotenuse, which is 12. Y is a leg. The piece of the hypotenuse it touches is the 10. And then the 12 is the whole thing. So these both use the entire hypotenuse, right? And then they also both use a piece of it, and it's whichever piece is touching it. Everybody okay with that? We're good? Anybody confused on that one? All right. So let's go down here. Now, when you go to set these up, you do not want to try and set them up based on the variable. Meaning, I know I'm looking for U, V, and W here, but I am going to set them up, not like try to set something up for U and try and set something up for V or that type of thing. I'm going to look at the pieces, the legs and the altitude, because that's where what everything revolves around. So I'll start with this. This is one of the legs of the big right triangle, right? And so since it's a leg, it gets squared. So W squared is equal to the piece of the hypotenuse that's attached to it, which is what? U, okay? This is the piece of the hypotenuse that's attached to it, times the entire hypotenuse, which is what? Is it 3 times U or 3 plus U? Plus, because you're adding them there to get the whole thing. Actually, I'm going to do U plus 3. It doesn't matter U plus 3 or 3 plus U. And then when I write it down here, because I got to multiply U times U plus 3, what do I have to make sure I do with that? Parentheses. So it's U times U plus 3. And then I stop right here, right? I'm going to pause. Then I'm going to move on, and I'm going to look at the altitude, okay? So here's the altitude. I know the altitude gets squared. In this case, it's a number and not a variable. That's okay. It doesn't matter. It's the altitude. It's not the variable that gets squared. So the altitude is 9 squared. Now the altitude comes in and actually divides the hypotenuse into the 2 pieces. So it's just the 2 pieces multiplied together, U times 3. Everybody good with all that? Then I move on to the other leg over here. So the other leg is leg squared. That's equal to the piece of the hypotenuse that's attached to it, which is 3, times the whole thing, which is U plus 3. Everybody good with all that so far? Any questions about where anything came from? Ask me now if you're lost, because I don't want you to get more lost. Say that one. I misunderstood. What did you say? Uh-huh. The second one, because it's a leg. The leg is the geometric mean of the piece that's attached to it and the whole thing. Okay, does that make sense? What are we confused about? Okay, well, the little rules that we came up with, these corollaries, all of these are just developed from the similar triangles. That's why we did it. Okay, so the why they actually relate to each other goes with the corresponding pieces of the similar triangles. When you go to the triangle and just start applying this, you just have to know what the rule is. The why behind it is because they're just similar triangles and we're actually setting up corresponding pieces. But to redraw the triangles and literally set up the corresponding pieces every time is a lot of stuff that you don't need to do because this just happens every time. So you just have to learn the pattern and understand the rules. You want to draw the triangles and do that? I wouldn't suggest it. I had somebody do that because they felt like it was going to make more sense to them, and then they just kind of got lost in this. Because if you accidentally draw one of these wrong, then nothing matches up. Okay? So just think about the only things that can be squared are these three things. And then it's just about what pieces of the hypotenuse it touches. The altitude touches both pieces, so they get multiplied together. This leg only touches one of them. This leg only touches this one every single time. You might feel better about it after we get through the second. Let's get this one done, the second example set up, and see if you feel a little bit better about it. Okay? And then, unless you have another question right now, you're just kind of still foggy. Okay. Did you have a question? Okay, but we're looking at the big triangle. Remember, this is a triangle with the altitude. So yes, W is the hypotenuse of the medium triangle. But that's just when we look at all three triangles. When we look at the big triangle, the hypotenuse is the U plus 3. Does that make sense to you? So we're using this as a triangle with an altitude drawn in. Yes, it creates two other triangles, and they're all similar to each other. But when we're doing this piece, and it's the altitude squared or the legs squared, that's always with the big one. Does that make sense to you? Does that help? Okay. Any other questions? Those are good questions. I don't want you to be confused about it. Because the 9 is the altitude, right? And so it cuts it into two pieces. So the rule is for the altitude squared is equal to just the two pieces multiplied together. It's whatever pieces it touches. So notice that the altitude touches these two pieces of the hypotenuse, right? This leg doesn't have anything to do with U. It touches 3 and the whole thing. That's why we did this. W doesn't have anything to do with 3. It only touches U and this whole thing. But the altitude touches them both. Does that help some? Anything else? You'll get there, I promise. All right, so now that we've got them all set up, now the reason we set them all up and then go back and try and figure out, what it is that we're doing is because sometimes they have more than one variable. This has more than one variable. Could I distribute that in there? Yes, but don't do that. Okay, you're just going to make it harder on yourself. This only has one variable. This has 2 in it. Overall, I have 3 equations and how many variables? Overall, 3, U, V, and W, right? So I have 3 equations and 3 variables. That means what I have here is a what? System of equations, right? Okay, but it's really not even a bad system because this one right here only has 1 variable in it. So I can handle that one and then just move on from there. But it's still technically a system. So since this only has 1 variable, I can actually get a number out of this, right? So we're going to go ahead and solve this one. 9 squared is 81. That's equal to 3 times U. So U is equal to 81 over 3. So what does U equal? 27. Everybody okay with that so far? That one I could get because it had 1 variable. Now, again, instead of, I don't want to distribute and get U squared times 3U because that's actually going to make my life more difficult. It's not really wrong. It's just not the best way to do it. And we want to learn how to, do things a little bit smarter and not harder. So we're going to take this 27, though, and I can plug it in for U, or I can substitute it in for U in both places. So now that gives me W squared equals 27 times 27 plus 3. Now, can I distribute 27 at this point? I can't. Can I? My question, not should I, but can I? I can. And I'm only saying that because sometimes I see people do that. I don't know why in the world you'd want to do that right here. Can you? Yes, and it's not wrong if you do it correctly, but no, the whole reason we didn't distribute it first is so we didn't have to do all that. I can go ahead and combine this so that I get W squared equals 27 times 30. So if I really just think about this as 3 times 27, what's 3 times 27? 81, like we just figured that out right here, right? Okay. So that means that's 810. So W squared equals 810. So W is equal to the square root of 810. Now, when you go to simplify this, I know that 2 numbers that multiply to give me 810 are 27 and 30, right? But I don't have to use those. Are there another set of numbers here that might work a little bit better? 81 and 10, okay? And that's something that, you should kind of get to a point where the decisions you make on how to break it down can help you, because now I don't need to go any farther. This is a perfect square, so I can just stop there. This is not a perfect square, and it's not a prime number, But I also don't need to do much more because there's nothing that's going to come out of it to be pairs, right? So I would break it up, but I just have to put it right back together. And so in the end, W is just equal to what? 9 square root of 10. Okay. Everybody okay with that? So now this one had 2 variables, but again, I know what U is. So I'm going to take this U and I'm going to plug it in right there. So that gives me V squared equals 3 times 27 plus 3. That means that V squared equals 3 times 30. So V squared equals 90. V is the square root of 90. What 2 numbers would probably be best here? Okay. And that's a matter of opinion, which one's best. 30 and 3 work fine, but if I use 9 and 10, I don't really have to do much more because, again, this is a perfect square, not a perfect square, not a prime number, but nothing else can really happen with it because there's nothing to pair it up with. So in the end, V is just 3 square root of 10. Okay. That's right. Work smarter, not harder. Any questions about this? Okay. All right, so then I want down here, we're going to look for these. Now it tells me what B and X are. So over here we're going to mark out what B is and replace it with the 6 square root of 3. And we're going to mark out what X is and replace it with 6. I'm going to give you a couple of minutes. I want you to try and get the 3 little equations set up. Okay? Just think through it. Try and write something down. It's okay if we're not right. We can always go back and fix it. Okay? But just try and think through it on your own. Okay. So don't panic too much. Give me the answers. Okay. So Rebecca, you're going to help me walk through this. I'm going to start with this leg. Like, it doesn't really matter which one you wrote first, but we're going to start with this leg. So this is a leg, right? Does it get squared? Yes, so if it's a leg, it gets squared. So we're going to have 6 square root of 3 squared. And then, Rebecca, what would that be equal to, do you think? Okay, so remember, whatever goes on this side of the equal sign always has to come from the hypotenuse, right? And if it's a leg, then it is equal to the piece that's attached to it. What's that? 6, okay, times the entire hypotenuse. And what's that, Rebecca? Huh? Oh, okay. Well, that's okay. Just tell me what is 6, but you're doing fine. That's why I'm help. This will help too. But just what's the whole hypotenuse? Like if this, what is it? Plus. Why? Because it's the whole thing, right? Like if this was a 4, 6 and 4, the whole thing would be 10, right? It's a y. I know it's kind of tiny. So the whole thing then is 6 plus y. Does that make sense to you? Okay. So the leg squared is equal to the piece that's attached to it times the whole thing. Does that make sense? So it's 6 times 6 plus y. Yeah, I forgot that you weren't here because you were responsible and came and got your stuff. So, but that's okay. You did. That's why I told you. I mean, she wasn't even here. I walked her through it. See, it wasn't that bad. Now, the 6 plus y, I meant to ask before I wrote it down, but then I was feeling bad that I made her answer it because she wasn't even here. But you have to make sure you put it in parentheses, right? If you have more than one term and you're plugging it into something, it has to be in parentheses. Now, does the 6 square root of 3 need to be in parentheses too? Because the way I have this written, the way it's written right now, what's the only thing being squared? The square root of 3. Are we supposed to be squaring the whole thing? Yes. So even though this is just one term, it still needs to be in parentheses, so it's the whole thing. Does that make sense to you? Okay, good. All right, so then we're going to pause on that, and I'm going to get somebody to help me with the next part. All right, so Eduardo, I'm going to do the altitude next. So since it's the altitude, does the altitude get squared? Yes. Okay, so it's h squared would be equal to what? Six times y. Y'all agree with that? You had a big question mark on it. Yes. Okay, yes, thank you. 6 times y. Because the altitude squared is just the 2 pieces multiplied together. Right? We good? All right, so then the last leg. Amy, This is my last leg here, and it's a. So does a get squared? Yes. So a squared equals what? Okay, we good? All right. Now, notice here, I put it as 6 plus y, and here it's y plus 6, because that's what they said to me. Is it the same thing? Yes, it doesn't matter either way. Okay. All right. Any questions? Did you get it? Does it make sense now? A little bit better? Like, it gets a little bit better after you do a few of them. Just remember, don't try and take the variables and square them all, because it isn't all of the variables that get squared, right? Sometimes it's a number, so you go by the piece, not the variable. Okay, we all good? Now I look at this. I've got 2 variables here, 2 variables here, and then 2 variables, or no, just 1 variable here. So I have to start here, right? That make sense? And so I'm going to start here, and then that means I need to square this first. So I'm going to have somebody help me do that. 6 squared to 3 squared. On. Can you tell me how I can get 6 squared to 3 squared before you just tell me what you think the answer is? Like, what do I do to get the number I want? Very good. Okay, so who in here doesn't really know what you would do with this? Just raise your hand. Okay, so pause on that. You're totally right. Because I want to make sure that if you weren't able to answer it correctly, you would be able to think through this. So I want you to think about this. If I had x times y squared, like this, doesn't this just mean x times y times x times y? Do we agree with that? Anytime you square anything, you multiply it by itself. And then, isn't this the same thing as x squared, y squared? Right? Okay. So when you have this situation, or this situation, you can think of it as one of 2 ways. And it's kind of whichever way makes more sense to you. All right? When you take this, anytime you square anything, you're multiplying it by itself. So 6 squared to 3 times 6 squared to 3. Or it is the power of a product rule, so you can distribute those, and it's 6 squared times the square root of 3 squared. And what she said was you multiply the 6 with the 6 and the square root of 3 with the square root of 3 is exactly what you do, whether you think about it this way or you think about it this way. But you have to make sure you know how to handle it. Does that make sense? We good? Yes. Oh, no, we're not done. That's just how you have to, if you don't think about it this way, then you're not going to get it the right way. Right. So then after that, when I multiply 6 times 6, I get 36, right? And the square root of 3 times the square root of 3 is what? 3. The square root of a monkey times the square root of a monkey is a monkey. Y'all can get that one right every time. Then ask you what the square root of 3 times the square root of 3 is, and you're like, I don't know. Like the monkey doesn't even make sense. I made that up. Okay? But the point of the monkey is it doesn't matter what it is. Whatever it is, you get the same thing underneath. We good with that? Okay, good. Thank you, On. And so then I have to distribute this, right? So I get 36 plus 6y. Oh, I meant to do this. Hang on. I'm going to erase that and redo it in a different color. Just trying to stay consistent in what I was doing. All right, so I'm rewriting the same thing. There was nothing wrong with what I wrote. I just didn't want it to blend in with that. That's equal to 36 plus 6y. Okay, so then what is 36 times 3? Well, what's 30 times 3? 90. 3 times 6 is 18, right? Then 108. So 108 is equal to 36 plus 6y. So 108 minus 36, 72. And that's equal to 6y. So y is equal to 12. We all good so far? So I got my y down. So then I'm going to take the y and I'm going to plug it in here. So I'm going to get h squared equals 6 times 12. So h squared equals 72. Square root of 72. Now, I know that 2 numbers that multiply to give me 72 are 6 and 12. But are there another 2 numbers that might be a little nicer to use? What's 9 and 8, or 36 and 2 even. Now, again, I know that a lot of you, I don't know if it was all of you, but a lot of you, when you learned to reduce square roots, you were taught to look for the biggest perfect square that divided in there. And I told you from the beginning, there's nothing wrong with that. That just shouldn't be the first thing that you learn, and it shouldn't be the only way you think that you can do it. Because sometimes you spend a lot of time trying to figure out what that is, and it's quicker just to do the tree. So if you learn with the smaller numbers that are more familiar to you to recognize those things in there, it'll simplify it for you. If you don't notice it and you use 9 and 8, because 9's a perfect square, right? But you can't just say at the end it's 3 squared of 8, because you can reduce 8 some more, right? Just kind of learn how to break them down where it makes it a little bit easier for you. Because if I do it this way, I don't really have to do much more, and h is equal to 6 squared of 2. Everybody okay with that? Then I'm going to take this 12, and I'm going to plug it in here and here, or substitute it in. So then that's going to give me a squared equals 12 times 12 plus 6. Okay. So a squared equals 12 times 18. So you can do it a piece at a time. You can do like 18 times 10 is 180, and then 18 times 2 is 36, so together it's 216. So a squared is equal to 216. So a is equal to the square root of 216. And that's one that you probably don't just know factors of. That's okay, because you know what? Those two work, right? So we can use 12 and 18. And then here, yes, I could use 6 and 2, but if I use 3 and 4, 4 is a perfect square and I can stop, and 3 is a prime number. Here, I could use 3 and 6, but 9 is a perfect square and 2 is a prime number. Does that make sense? And it just kind of makes me, I can stop my tree a little sooner if you know what to do with this correctly. So then this is going to give me a equals, all right, well, the square root of 4 is 2, square root of 9 is 3, and then these two have to stay underneath. So that means a is 6 squares. 6. Everybody okay with that? Any questions? Yes. Well, I know. That's why I knew that we needed more. I knew I needed to do more examples with you. We just didn't have the time. And that's also, I don't know if I said this or if you noticed it on your calendar. It's not due until Monday, because I wanted you to have time to work through it. You have a little bit of time to work in class, and then you have time to get your questions answered. You need to keep up with your work. Your work needs to be semi-organized, all right? Otherwise, you're not going to be able to keep up with what's what, all right? Box things, do whatever it is that you need to do. Any questions? We good? Awesome.